Right, so what this white box testing does is shows the route through your code. Okay? I only want to see 4 of these tests done. You just got to draw a diagram. It is only suitable for code that has some decision logic in it. So something like this, which is just do that line, that line, that line, that line, that line, on these graphs would look like this. And the route through the code would be that every single time. So we can't do it for those. Okay, so don't attempt to do it for one of those, it won't work. So you need to find any of your code that has got ifs in it or loops in it or anything like that. Most of your code won't have loops in it, but it will generally have ifs because of the way Unity works. So if I'm in bird controller, so I'm going to scroll down, and I've got a couple of different ones. So I'll do these 2. So we do them separately. So I'm going to do this one here. So I'm going to create a little diagram, and I suggest that you do it just on paper and scan it. It's up to you. You can do them in Visio, or don't do them in Word or Paint or whatever. Right, so 2 steps to the process. The first is labeling up. Okay, so if you take the code and generally it's best to use letters for this. So if we just label each line that we've got, and it is just the lines in between the container braces. So I've got these 4 lines. So I'm now going to lay this out on my graph. So I start at A, and then immediately when I get to A, I've got a decision. I'll either, if this is true, do this bit of code. So I'll go B, C, D. If it's false, I won't do this at all, and I'll just go down to D. So all I'm going to show is that I either go B, C, and then D, or if I don't do this code, I will just go straight from A to D. So graphically you see straight away, if I look at what A represents, I can see there's a decision. The only other thing you've got to then do is just do a little table to explain what the decision at A is. So you don't have to write this code out, just say, like space press, which is what that was for. I can't spell press, I don't know what I'm spelling it. So space press, do B, else do D. And that's it. Obviously that's a really trivial one. But in essence that's what we're going to keep doing. Now you could argue that B doesn't do anything, so you could strip that out if you wanted to. Okay? I'll show you that on the next one, which is a bit more complicated an example. Alright, so that's in essence what we're doing. So it's just a little diagram to represent the path of the code, and then just some statements just to say, and you can organise this how you want. You know, I have got other videos that say do it a different way, but I don't mind as long as you tell me what the decision making mechanics is. That's all I want to know. So let's have a look at this trigger one. It's a little bit more complicated, this one, because it uses a switch statement, which is the bigger form of it. Right, so I'm going to do the same thing. I need to make sure I've got a sensible title for this. So I can't remember what this was now. Oh, bird hit or something. Bird hit something. You can just use the name of the routine. It's up to you. So I'm going to label this up first. Right. I'm not going to bother with these braces. I'm going to label the end. I don't know what it's going to be. I'm just going to put a Z at the end. So I've labelled the first bit of code, and then you've got to understand how switch works. If you've got a switch, how many people have got a switch? Nobody got a switch? No, nobody got a state machine or anything.
Just big ifs.
Big ifs. Right. Anyway, but essentially a switch is just a nice way of formatting a loads of if, else, if, else, if, else, if, which you might have. Right. So that's going to be the decision line. So looking at what tag with it, so you can read it quite easily. And then we're going to get to this part. Okay, so, and then we've got some linear code. Now I could write C, D, E, F, but because it's linear, I'm not interested in what goes on. I'm only looking at the path. So I'm actually going to say, you know what? that block of code I'm just going to call C. And then this block of code, I'm just going to, so it's all linear code, just one line after another, I'm just going to call that D. So actually my end I'm just going to call E. Okay, so I'm not, you're making yourself a job if you go A, B, C, D and do all those. So I'm just saying, right, there's some sections of code. So when I come to draw this, I get A, and then I can either do, and even I probably don't need that B, because I'm just saying this is all that block. I can either go off and do C or D, and then we'll finally end up. It doesn't matter if the letters are not in sequence, as long as they're just labelled properly. So the key thing you've got to show me is just a bit of your code with some labels on. And again, this is why I say do it by hand. If you just print off and hand draw it, it's easier. A little graph, and then again we're going to do a decision. We've got, wherever we get a fork, we know we've got a decision. So I'm just going to say at A, if the tag is pass check, then I'm going to do C. Now I've got default here, so it's at any other tag, because don't care about anything else. Any other tag, we're going to do D. That's it. Okay. Right. I'll do one more, so I'll find another one. Yeah.
How come you didn't label on trigger enter like a?
Because really, that's the start of it. The first line after that brace is the start, so I don't need to label that. I could do if I wanted to. If, let's say I called that, I don't know, what have I got? Let's call it Y. All it means is on my diagram I've got that. So I say, I do Y, then I do A. So we don't really care about that because it's not to do with the path, is it? So you can do that, that's not wrong. I'm just trying to make it easier for you when you come to do it. Right, let's have a look at another one. Let's have a look at... no, let's have a look. What's this one? Right, this is a little bit more complicated, this update score one. So let's have a look at this one. So this has got an if inside an if. Right, so my first thing is to start off labelling it up. Okay, so I'm going to label the first if. Then I've got some code, so I'm going to do each line this time. Then I've got another if, so I'm just going to call that C. And then I've got this line of code. The braces don't matter, you can completely ignore those. So I'm going to call that D. And then I've got these two lines of code that are just one after the other, so I'm just going to call those together E. I need an end marker, so I'm just going to say F at the end. Okay, so I have to pretend I'm the computer following it through. So I'm going to start at A. If this is true, I'm going to do B. So I say, right, okay, I'm going to go to B. If that isn't true, let's look for the dashed line, then we finish. So actually, it's going to look like that. So this can actually, on that first decision, do nothing. And the whole code stopped. Let's follow B through then. So we do B, and then we get this decision at C. And again, we either do this, which is D, so let's just follow that through. And then we do E. Now, you can make these diagrams as nice as you want. They look better with curves, I think. Or you can make them look awful. Don't have the arrows crossing. That's the key bit. Right, so that was one decision. If that isn't true, so if you haven't beat the high score, we don't do this code. So we'll drop straight to E. So we can show that. So this is quite a nice diagram because it shows us two decisions and there are some more complicated paths through. Okay. The reason it's called white box testing is because we can see the code. Does anyone know what the opposite of white box testing is? Why is it called black box testing? Because you can't see. They're electronic terms. So this would be when you can see the circuit that you're trying to diagnose. But if you've got a silicon chip that has got like eight legs on it and a bit of epoxy over a chip, all you know are the inputs and outputs, and that's a different type of testing methodology. Okay, but this is quite nice. I quite like the white box testing. So again, So at this time I've got two decisions to write down. So I'm going to say at A, if we have a score, that's what the null bit means. Do B, else end. So that's F. And then we've got another one. So I'm just going to say and it was at C. And if let's have a look at it. So if score beaten. Notice I am not just replicating what's in the code. I'm actually giving a bit of meaning. So I'm saying, oh yeah, what that means is score's been beaten. So if the score's been beaten, we do D, else we do E. Okay, and that is it. So all I need from you is 4 as part of your testing evidence. Obviously, if you're doing it for real, you'd probably write them all out, but we're not bothered about that. Although, to be fair, we probably wouldn't be using an automated tool to do it and test them. Anyone got any queries about that? So pretty straightforward. Don't overcomplicate it. I'll upload this video. There are other videos on there as well. But if you've got any queries, if you've got something weird like a while loop or anything going on and you want to do that, just nod and I will come and have a look at what you've done. Okay? Right. I'll stop that and upload it. Thank you.